Kaushal, welcome you all in today's episode of Science Simplified only on Bharata First. Through this platform, we provide a unique opportunity to ask questions related to science and technology, which will be answered by the experts. Let your curiosity out and ask questions through a form whose link has been provided in the description box below. Do make use of this opportunity. Now, I would like to introduce to our science expert, Dr. T.V. Venkateshwaran, who is here with us to answer the questions sent to us by our viewers last week. Dr. T.V. Venkateshwaran is a senior scientist at Vigyan Prasar, New Delhi. He is also founder of India Science Wire. He writes regular columns on the developments related to science, technology, and society. So, the first question for today is,
Namaste sir, my name is Saishri. I am currently pursuing engineering final year. My question is, does the parallel life or parallel universe exists as proposed by many scientists? If so, what is the phenomena? Thank you sir.
The parallel universe is a concept, more like a hypothesis that's been proposed by some physicists to account for certain anomalies or surprising things that we see around in our understanding of physics. Understanding of physics as it exists today. Tomorrow things may change. There is a very famous experiment called as Schrodinger's cat experiment. I'll just try to describe that. That will kind of give us idea of what the parallel universes are talking about. So, in the Schrodinger's cat experiment, the Schrodinger quantum physicist said that suppose you put a cat in a box. Inside the box, you keep one radioactive atom, not many, only one. Okay, one radioactive atom, and then one mechanism. That is, if the radioactive atom radiates, then that radiation will be captured by a Geiger counter, and that Geiger counter will activate a system which will induce, let's say, fumes, toxic fumes inside that box. Cat will die. So cat will be alive as long as the atom has the naturally radioactive atom has not decayed. The moment it decays, the cat will die. That's an experiment. Okay. So you are putting it in a box. You cannot see it. It's a black box. You have put everything inside. After 5 minutes, can you say that the cat is alive or dead? We don't know. Because the radioactive atom, although we can calculate off-life, it's only probability, right? It's only a probability that it will take so many years to decay. Sometimes it can decay immediately. Sometimes it may decay after millions of years. We have no idea, right? So, what can you tell about what is inside the box? When you open, maybe the cat is alive, right? So, but can you really say from the time you close the box to the time that you open, the cat was alive? How do you know? You only guess that it should be alive. Okay. So, to overcome this, one of the ideas that has been proposed in quantum mechanics called as superposition. So, what you say is that from the time that you seal the box till the time that you open the box, the cat was in both living and died situation. It was in that superposition. Okay, so that's called a superposition. The moment you observe, the superposition collapses and becomes one, either dead or alive. Okay, so then what happens to the other one? That's a question. That is where the parallel universe concepts come. So one of the parallel universe idea is that whenever you have such forking positions in world history, whether the cat is alive or not, you are not knowing. It was superposition as long as the box was closed. When you open, it is alive. So what the parallel universe is saying is that there is another universe where similarly a person is opening, but the cat is dead. So both are happening if you look at the whole universe. Okay. So 50-50 per chance. So either it's all happening, that's also it's happening. But you are in this universe but there is a parallel universe where somebody like you, parallel you, is there who has opened that door and find the cat dead. But whereas you are finding the cat alive here. So it's like this. Suppose if I want to go out for a drink, okay, why not? You go. Sometimes you say no, you don't go. So if you say why not and go, maybe you both fall in love, you get married, you make a family. Maybe you say no, I'm tired. Maybe you both go to the two different worlds, so the life histories are completely different, right? So this could have happened, that could have happened, right? So the parallel universe theory says that both universes are there. It's not that only one has happened. You are existing in one, and then you are feeling that, but a parallel you is existing in another and feeling that. That's the parallel universe idea. So every time, suppose you are proposing to a girl, I mean, of course, if you're a boy, if you're also a girl, that's a different issue. But when you're proposing it to a girl, maybe you accept, maybe you reject. Okay, you again propose, maybe you don't propose. All these possibilities. So multiple worlds emerges, and multiple worlds exist. That's this theory called as multiple universe theories. But in the multiple universe theories, there are different types of multiple universe people are talking about. One is only the extension of the current one. Okay, there is a current universe, and there is a universe which is beyond it. It's an extension of the current universe. The other is called as bubble universe, where it means that, like our universe, there are also other universes which are like bubbles in a let's say water surface. Okay, so like bubbles, I mean, they exist. Then there are many levels, many worlds, which is like as I was telling you, in one you decide yes, the other one you decide no, right? These are also parallel universes. Okay, then there are also mathematical universes. So the mathematical universes are basically for ease of computation and understanding. They are not really real one that exists. They are all only mathematical constructs. Okay, so these are all different theories of multiverse which are in existence today. But I should also point out that this is not the only theory to explain the some of the intricacies of quantum mechanics. There is another very famous theory in quantum mechanics called as hidden variable theory. So in the hidden variable theory, none of this is needed. Okay, but we don't know which one is true because we don't have experimental proof as of now.
Hello, I am Mishika Dheer. I am a student and my question is, what is quantum computing? How India can explore the dimensions of quantum computing with respect to economic and strategic development?
Very good question. So let me share my screen and then answer. Okay. So there is a very famous quantum mechanics thought experiment. It's not an experiment which is actually performed, but kind of in your thought you can perform this. So it's called as thought experiment. Assume that there is a cat inside a sealed box. Okay, so the cat is inside the sealed box. Inside that there is a radioactive material. Okay, the radioactive material, there is only one atom. Okay, so that radioactive material can decay at any time because there is only one atom. The moment it decays, the radioactivity uh, actuates a mechanism whereby a hammer falls on a glass vial in which there is poison. Okay, so if the hammer falls, the poison will spread inside and then the cat will die. But if the hammer doesn't fall, the cat will keep on alive. Of course, you will ask what will the cat eat, etc. In thought experiment, we don't discuss that part. We assume you have some way the cat is able to eat something or whatever, right? Yeah, this is not exactly about cat. It's a thought experiment to make it more interesting. Now it's a sealed one. Okay, so you cannot see what is inside. Let's say after a few days, can you tell whether the cat is alive or not? No way. But suppose you open and you find cat is alive. Can you say that for the past 5 days the cat was alive? That's an important question. Okay, for which our common sense will say that yes, of course, cat should have been alive. But how do you know that cat was alive? What is the proof that cat was alive? That's a big question. Okay, so within quantum mechanics, the idea is to say that from the time that you seal and from the time that you opened, okay, opened and saw whether the cat is alive or dead, during that whole period, the cat was simultaneously alive and dead. This is what is called as quantum superposition. Okay, so in quantum superposition, you exist in two states simultaneously. Which one? Once you observe, it will be clear. Okay, till you observe, it exists in two positions simultaneously. Uh, One of the way that we can see that simultaneous existence is, say, for example, you have an electron gun. You send an electron. Let's say there is a slit like this with the two holes. Okay, normally we will expect that the electron will go like this or electron will go like this. When it goes like this, it should hit the screen somewhere here. If it goes here, it should hit the screen somewhere here. Only two lines should fall. But that's not what actually happens. What happens is that you have parallel lines like this. Okay, in the screen you will find a parallel line like this. The center one will be the brightest, then less brighter, even less brighter, like that. The parallel lines will keep on continuing. So what does it mean? So if I look at a line like this, okay, this line like this could have happened only when a atom goes like this and goes in this way, which is not the usual format that we will think a particle will move. But suppose if this was a wave, electron was a wave, then this is what we will observe. Okay. So now the question is whether the electron went through this slit or this slit. That's in superposition. If you look at a particular electron, okay, a particular electron here, making a dot here, whether this came from this slit or this slit, you cannot say. It's in superposition. But the moment you start observing, that is, you observe the electron, then what will happen is that the electron will go and fall on only one point. Okay, so the superposition is released. So this is the quantum idea of superposition. Similarly, there is something called as quantum entanglement. What does this quantum entanglement mean? Suppose if I take, let's say, a square and a circle, okay, a square coin and a circle coin. I take two of them, okay, out of a box which contains squares and circles. Then I have four possibilities, right? I can have a circle circle or a square circle or circle square or square square. Then each of them have 25% possibility. This combination has 25% probability. This is something that we know very simply. But suppose if there is a rule which says that if the first one is circle, the second one should be circle. If the first one is square, the second one should be square. Then what happens is that we have something called as entanglement. What happens in the first decides what should be the second. Here, whatever be the first, whether the first is circle or square, the second one is not dependent. When the first one is circle, the second one can be circle or can be square. If the first one is square, the second one can be a circle or a square. Both are possible. But here, because of the entanglement, if the first one is circle, the second has to be circle. If the first one is square, the second has to be square, right? So this is called as quantum entanglement. So this is another property in quantum mechanics. Okay. So there is something called as decoherence. That is, if when something is in a superposition, when you observe it, it either becomes heads or tails. Say, for example, if I throw a coin, the coin is spinning in the air. As long as it is spinning in the air, you don't know the result, right? So it can be either head or tail. So it is in a superposition. But the moment it falls and then you observe that it is head, it decoheres. It becomes either head or tail. It resolves into one, right? So these are all some quantum mechanical idea. From using that quantum mechanical idea, you can create certain computer structure. Okay. Normally, in an ordinary computer, what we create is what is called as a switch. Okay, so the switch can have two positions: on, off. Okay, on, off. So you can call on as 0, off as 1. you can call any name, doesn't matter. Okay, so because it's a switch, it can only have two positions, on off, 0 1. Okay, so binary, so that is bit. Okay, now I can have quantum bit, qubit. So in the qubit, remember that things can live in a superposition, right? So there is one position, there is another position. Now I can have a superposition, right? So now I have by same switch, here I can only represent two, but with the same switch I can here represent multiple points. Okay, here there are only two possibilities, but here I can get multiple points. So because of this, that it can be either 0 1 or both, there is a superposition. The computation with the quantum system will be much faster. Okay, in the traditional system, you go one by one and then find the answer. But in a superposition, I can change the possibilities. Okay, as many possibilities I can sort out, and then I can get the answer faster. Okay, so that's the quantum mechanics that's used. For example, one of the quantum computers structure as of now looks like this. Okay, so at this point is where the qubits are stored. Okay, and you have to cool it with liquid helium because it has to be at very 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 low temperature for quantum mechanical effect to take place. Okay, here is where the qubits are stored. So if you look at the specific qubit, it will look like this. Okay, so it will have a sealed metal casing, and inside it you will have the coolant going around so that you can keep it cool. Okay, so then you will have electrical component, so basically leads coming out of this bit, and there is a small pit like cavity where it can store one qubit. Okay, so that's how the qubit systems are done in quantum computing. So the quantum computing is essentially using quantum mechanical ideas like superposition, decoherence to build a computing machine. And because in the quantum mechanics, it's not only 0 or 1, both are also possible. Then more information can be stored in a less place. So more faster your computations can take place. That's what is happening in a quantum.
I'm Abhip Sharat and I'm a 12th grader. My question is, what are microplastics and how they are going to pose extreme threat to surviving of living organisms? How can we effectively deal with them?
See, there are various kinds of debris that can come from plastic. Okay, so when you have big plastics, okay, something above a meter, like a can or a net, that kind of a stuff. Okay, these are called megaplastics. So what can these megaplastics do? For example, in a net or a big polythene bag, a big animal can get trapped. Okay, then you have macroplastics. Macroplastics are between 1 meter and 2.5 centimeter. So bottles, our carry bags, all come in that macroplastics. So in the macroplastics can again entangle with animals or creatures in the marine environment. It can affect the biotic issues. Then you have something called as a mesoplastic. Mesoplastics are like, say, for example, the Bristol. Okay, they are all very tiny, right? So it's basically about 2.5 centimeter to about 5 millimeter. Then you have the microplastics. So the microplastics are things which are less than 5 millimeter. Okay, so to answer what is microplastics in a very simple way, they are all plastics which are less than 5 millimeters. Okay, so this 5 millimeters can accumulate, and then it can be eaten by animals, and then there is something called as a bioamplification can take place. In addition to microplastics, today people are talking about nanoplastics. So anything less than 1 micron is considered as a nanoparticle, plastics. Okay, so these are all the various kinds of plastics. Today, what we are doing is that we are producing plastic. Okay, at that time there is a spill, so there is a pollution. We are using plastic. After plastic, I mean, we litter. That litter goes into our environment. Okay, then waste is collected, waste is put in landfill. That landfill leaches and then takes it to the environment. So there are the way plastic is goes into our environment is at all the stages: production, use, and waste treatment. All stages it is there today. Okay, so microplastics are plastics which are less than 5 millimeter, as I said that. It starts with plastic littering. Okay, this plastic littering becomes with the sun's ultraviolet rays, or maybe mechanical, or maybe microbial. All this acts, and then these plastics are fragmented into microplastics. So when it becomes microplastics, it's less than 5 millimeter. So it can mix with soil, it can mix with water, it can be leached into a water body. Then a fish eats it. So the seabird which eats the fish gets a lot of microplastics. Similarly, aquatic life which eats the fish gets a lot of microplastics. And then when we fish and use that fish, the microplastic come back to us. Okay, so this is a cycle of microplastics we see around. How to stop this? How to stop this is to go for what is called as cycle economy. Okay, what is it? Whether it is in production or use or waste, you cycle the material, right? So there may be a small amount of spill, but then reduce it as much as possible. And then after that, uh, uh, littering you stop. You arrange for recovery by, let's say, paying for old bottles and so on and so forth. Okay, and then the waste, instead of throwing it away, use it for recycling or conversion into other products. So this kind of a circular economy, where we are not throwing anything away as actually waste. We may be throwing it away as waste from a particular process, but that should become an input for next process. So if you do it like that, then the microplastics can be substantially controlled.
Hello everyone, I am Palagupta. I am a botany graduate and also I am preparing for civil services. My question is, what is CRISPR-Cas9 technology, which has been in news in relation to COVID-19 vaccine production, and what are its prospects in future drug industry? Thank you.
So CRISPR is actually clustered, regularly interspaced, short, palindromic repeats. That's a short term for CRISPR. Palindromic is something like a word like Malayalam. Whether you read this way or that way, it's same, right? So if you look at the DNA, we all know that it's written with four alphabet, ATGC. So when it is written similar to Malayalam, you can have a DNA sequence where whether you read this side or that side, it looks same. Okay, so if you write a DNA sequence and you read it left to right or right to left, it is same. That kind of a palindromic is what is first of all talked about. It's repeat, meaning that it is repeating again and again. It's not only once in the genome, but it is repeating again and again continuously. Regularly interspaced, meaning that the gap between them are roughly same. There may be slight variation, but roughly same. Clustered, it's in one single place in the genome. This is the whole idea. When I explain, we will understand what it is. Okay. So basically, it's CRISPR technology is basically for editing a gene. One of the most talked about CRISPR technology is CRISPR-Cas9. What is this Cas9? Cas9 is basically a enzyme. This enzyme is like a scissor. Okay, you have a scissor to cut up paper, right? There are also scissors which can cut thin metal sheets. You can't use a paper cutting scissor to cut a metal, right? But you can use a different scissor for it. In the same way, Cas9 is an enzyme which can cut the DNA, okay, in some places. But Cas9 has a special property which is not there, for example, in the normal scissor which can cut a paper. If you have to understand that, we can look at, for example, a very simple thing that most of us would have used. I'm sure all of you would have used Word document, right? In the Word document, there is a facility called as find, right? So you type a keyword, the Word document cursor will go to that particular keyword, whatever word that you're finding in a document. In the same way, if I attach something called as a guide RNA, what is the difference between RNA and DNA? DNA is double strand. RNA is only one strand. Okay, it's only one strand, right? So that RNA, I create a RNA with a particular genomic sequence and attach it with, calling it as a guide RNA, and I attach it with Cas9. Then what will happen is that this guide RNA will go and attach to the DNA wherever the exact RNA sequence is matching in the DNA. But suppose if there is no matching in the DNA, then this guide RNA will not stick at all. Okay. So the guide RNA is prepared. It's called, sometimes called as primer. Okay. It's prepared in a particular sequence which will exactly match some part of that DNA. It's something like the find. Okay. So the Cas9, when you attach, then this guide RNA and the Cas9 together will go and attach to that particular part of the DNA. And then what happens is that the enzyme will start acting. When the guide RNA goes and attaches to the particular part of the DNA, the Cas9 will start acting like a scissor and it will cut the DNA. Okay, exactly at that space. This is what is the essential principle of CRISPR technology. Like I said, Cas9, you also have other enzymes, okay, which can also work as a molecular scissor, okay, that also are used. Cas9 is the most famous, but others are also used. So when you use CRISPR-Cas9, so once you cut, for example, you can create a deletion. So you can cut away some portion of the RNA and then create a new RNA without that part of the genomic information in that thing. Or you can introduce a new DNA inside it. Okay. I mean, you can delete or you can add more, right? So this is what is called as gene editing. So the CRISPR-Cas9 technology is generally used for this DNA editing. So you have a chromosome, there is a DNA in that chromosome, you create a guide molecule which is exactly fitting that part of the chromosome DNA strand. Okay, there is a enzyme that you have attached to the guide RNA, Cas9 or something like that. Okay, so it cuts, and now you can create a healthy DNA strand and you can attach. So you can do, for example, gene editing cure. These are all some of the possibilities. Now let's come to the COVID. COVID virus is also a genomic sequence, right? So now what I can do is that I can attach it with some molecular scissor. For example, in one of the instrument, I mean, one of the technique, Cas13, a particular kind of a protein, is attached with a molecular probes. That is basically you have created, taken the swab, okay, from nasal swab. Now what will happen? You add fluorescence to the material. So when the Cas9 protein cuts the DNA, then suddenly that thing will start glowing. Okay, but this Cas9 protein has a guide RNA, which is exactly matching the virus, some part of the virus, not the complete virus, some few portions of the virus. So in those places, if there is a virus genome in your sample and the virus genome has been cut, then the fluorescent will light up. Okay, so easily you can see whether that particular sample is containing the virus or not. Okay, that is one possibility. There is also another way, for example, CRISPR technology has been used, which is basically like in a strip paper. One of the method that was fabricated by India, the IGIB, it's called Felidor Test. Okay, in that what you do is that the CRISPR-Cas9, if it attaches, okay, with the RNA, then it will go and attach to the test band. So if it attaches to the test band, then the antibody will attach to a gold particle, which will go and attach itself to the control band. So if there is virus in the sample, then this two, both the test band and the control band will glow. So then you will know that there is virus or not. Okay, so this is ways of using the CRISPR technology. You can also use CRISPR technology basically like you collect the sample, you have the thing, then you take two genes, not just one gene, okay, and then create a visual readout in the same way like this Felidor test, okay. So now when you are getting two genes, then your sensitivity increases. I mean, even if there have been some molecular changes, I mean, if there is a variation, still you'll be able to find out through this. This is basically the technology which is used in the CRISPR.
Hi, I'm Scan Kapoor, a student. My question is, what is the meaning of Sunrise mission of NASA? How can it help in understanding the evolution of solar particle storms in space?
Very interesting mission that the NASA is proposing to send. It's called Sunrise. Sunrise means Sun Radio Infrometer Space Experiment. Sunrise. So what it will have is it will have six CubeSat. CubeSat meaning very small satellite. Okay, in a shape of cube. It will be going around Earth in this configuration like this here thing. Along with all the six CubeSat together, will create a 3D map of the places where there are bursts happening in the sun. Okay, so because you can continuously watch the sun using this kind of a 3D map, wherever there is a like this, wherever eruption on the sun happens. Okay, so you can pinpoint the origination and then how they expand toward the outward space, how this sun explosion is expanding outside space. If we get this kind of information, then we'll be able to determine uh, what initiates and accelerates this jets of radiation in sun. These are all things that you can understand in the sunrise experiment. Okay, so essentially sunrise experiment is to observe for solar particle storm. So what is solar particle storm, right? So sometimes on the surface of sun there are eruptions. Something like, for example, when you are burning, let's say, wood, suddenly you will find a piece of flame flying away, right? So in the same way, in on surface of sun also there are some eruptions. When that eruption happens, large number of charged particles will be spewed into the space. Okay, so that there will be a surge of this particle called as solar wind. The wind will become a storm. Okay, normally there will be wind, but that wind will become a storm. Okay, so these storms are dangerous for our space effects. Like if you have electronics in space and things of that kind, this storm can completely destroy it, right? So uh, if you can observe and if you can forecast, then you can shut down your space assets and then save uh, 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 electronics in the space, spacecraft, satellites going around Earth, even planetary travel. If you want to travel to moon or other planets, okay, you this will be very handy. This information will be very handy. So the CubeSat will look something like this. Okay, basically it will be above the ionosphere. Because it's above ionosphere, it will be able to see the radio waves coming from sun. So it will not be an optical telescope; it will be a radio telescope. Okay, so that's why it's called as an infrometer. So it will be a radio telescope which will be used to study the eruptions happening on the sun's surface.
Thank you, sir, for your insightful explanation of the questions. On this note, it's a wrap up of today's episode of Science Simplified only on Bharata First. Be scientific, be inquisitive. Please like, share, and subscribe to such amazing content on Bharata First. See you soon.